free fall, the acceleration due to gravity. Earlier we mentioned that acceleration is only going to be constant. That's the only case we're considering in this chapter. One of the best examples of a constant acceleration is the acceleration due to gravity. All unsupported objects fall towards Earth with the exact same acceleration, and this acceleration is constant. We call it the acceleration due to gravity, and is denoted by little g, lowercase g. G is a constant near the surface of the Earth, and it is equal to 9.8 meters per second squared. So by the units you can see it is an acceleration. All objects accelerate towards the Earth at the same rate, regardless of their mass. This is a very interesting video, so at this time please click on it. It shows an experiment done on the Moon in 1971 by the crew members of Apollo 15. Consider an object, like a baseball perhaps, that is thrown upwards with initial velocity of v0. So right over at this position here, it is thrown up. It goes up in a trajectory and then comes down. So, some questions. What happens when it goes up in terms of its velocity and acceleration? What happens at the top? What happens when it goes down? And what happens when it lands? Take a few minutes and discuss your thoughts about this. G is constant near the surface of the Earth. We didn't mention whether it changed if you threw a ball up in the air, or if the ball stopped, or if the ball was coming down, but you can see here, wherever you are in this ball's path, G is always constant. It is negative 9.8 meters per second squared. So once you throw the ball up, the velocity is in the up direction. Since acceleration is down, that means the object starts slowing down. The minute you throw it, it starts slowing down. At the top, it will stop momentarily. And the way you can see that is once it starts falling down again, it is speeding up. So the only way you can go, for example, in this direction, where you have a positive velocity, and in this direction you have a negative velocity because it's going down, the only way to get from positive to negative is to go through zero. So at the top of this trajectory, the ball has zero velocity. Then it starts speeding up, and then right at the bottom, it has its original velocity just in the opposite direction. So actually the more correct way to say it, it has the original speed, but the velocity is different. It is opposite. For example, if the velocity was positive here, it's negative here. Here's another way to explain what's happening. We're going to use velocity vectors. v0, that's your initial velocity, and v will be your final. On the way up, your maximum velocity is once it leaves your hand. It immediately starts slowing down due to the acceleration in the down direction until at the very top there is zero velocity. So what was going on is, see how the velocity is shrinking? v1, v2. However, notice that the acceleration is constant the entire time. The acceleration is always negative 9.8 meters per second squared. It is pointing down and it is equal to g. Now, on the way down, you can see the velocity increasing the entire time. And acceleration is still pointed down. That is the big point here. The acceleration is always down, and the object continues to speed up as at each point the acceleration is increasing its velocity. And at the bottom, it has the exact same speed as it did when it started, so v0 here equals v final here. And the velocity is different in that the direction is different, but the magnitude is absolutely the same. One more way to look at this issue. For any object thrown straight up in the air, this is what the velocity versus time graph looks like, or in short, the velocity time graph. We have time over here on the x-axis, and we have velocity on the y. The object starts, it is thrown upward with an initial velocity of v0. That's right over here. Immediately it starts slowing down until it reaches its maximum height where its velocity is 0, and then it starts falling, increasing its speed the entire time, and it has an acceleration equal to negative 9.8 meters per second squared. Right here at the bottom, when it completes its trip, it has the same speed, but velocity is different. The velocity is the negative of the velocity it started with, or in the other direction.